So today, this is the second event that we will be presenting, or I should say the second topic. This is to do with 3D Evolution, our multi-CAD converter. So this deals with translation between different CAD formats and other various items such as healing, defeaturing models, and exporting PDF as well. So without stealing too much of his thunder, I will go ahead and pass it over to Mr. David Sellerman, who will be presenting the topic today.
Well, hello everybody. Let's see, for some reason your screen is kind of stuck. There we go. Okay, so today's focus is really the foundation of the word interoperability in the CAD space. It's really interesting because as much as we in this industry have come to the conclusion that a lot of these CAD organizations have the ability to open up their competitors' products, the challenge that you have is that some of the product data quality of the actual model coming in does not match the kernel. So what we're going to show you today as part of my presentation is the foundation of how CoreTechnologie started 20 years ago, which was to move away from step and then write the data direct without having imprecisions or free edges in your model, or even taking it one step further. We are one of the very first companies in the world that actually became VDA certified. And since then, we now have the other product data quality standards also in our product as well. So the first thing I want to do is I'm going to have Marco in the background. So let me introduce you guys to Marco. If you were at the earlier presentation, you'll know that he's not only our senior application engineer, but has over 15 years of experience working from Honeywell. He implemented our technology for data translation, geometry simplification, and the LOTAR requirements for long-term data retention in their PLM system, developing automated processes. So although you're going to see a lot in the beginning of how this is done interactively in our technology, please keep in mind that everything that I show you today will be done also in an automated process, because this is really considered to be an engineering chore. The CAD departments don't want to clean models. The computer-aided engineering departments don't want to, and certainly the manufacturing departments really just want to gather information from that data set. So let's talk to you and show you how you would do that. So Marco?
Yes, David. So, well, our first topic is the EDM Data Manager.
Okay. So if you want to open up EDM, so with CoreTechnologie, we have two batch processes. One of them is a web interface. So in some cases, our customers will actually change, if you notice the top menu, and have this website available for all their users globally. And they'll allow their server-based system to start running chores where folks are able to submit jobs. I will mention a couple of use cases and our reference customers as well. So ABC Group, as an example, wanted to implement our EDM in their batch process to, in their case, they were using JT as their standard format. And they were able to have users submit jobs and then submit those jobs for specific tasks and then get the results of them without actually opening our technology interface. So let's just go ahead and just run a translation right now, if you would. So standard translation, we already have scripts that have been developed. And in this case, we're just going to open the advanced heal model, if you will. That's fine. So Marco's going to be driving this, yep, number one. And just pick the CAD part model. So in this case, it's a CATIA V4 model. Oops, didn't pick it up. And so you can either choose a specific part in this area, or you can choose an entire folder that you're requesting. In the case of ABC Group, we actually set up their batch process. Instead of the user going in and submitting a job, it automatically does their entire database. So it will scan a folder, and anytime there's new data in that folder, it will translate the file. And in this case, he can even go one step further and say, okay, I want to heal this model once. I'm going to stitch it once. Or you can choose twice, so stitch it once. If you would, stitch it. Just choose one. And, oh no, it's, okay, there you go. And then you can either run this now or you can run it later. We're going to go ahead and run it. And then you can see the batch process showing all the jobs in the queue. An administrator, if there's an important job that needs to get done, he can move the jobs up or down in the scheme. And then you can also view, once the job is finished, you would get a log file showing the results of the data set and tell you exactly where that data set is. And it will give you a nice little, quick little view of that. And let's show you what really happened in this queue. And I'm going to do the exact same model and show you the results in our interface. So you can see at the end of the day, what it does is the first thing in just a basic translation is let's just check the model. Thank you. He's going to turn on those free edges. We're going to just do a basic check, and we can see here in the batch process it determined that there were considered to be 34 bad edges out of a total of 27 imprecisions out of them. And it will highlight the items listed right in the model. So when you're doing this in a CAD system or you're using a step file, even though you write out a step file from CATIA and you bring that same step file in an X, you're not getting the same results. And I'm going to show you that as well. So in this case, we're going to heal a model like it did in the batch process. And we're going to notice that it goes to 23 bad edges. I'm going to go to configurations and see if I can clean this up through the same way our interface is. And we're going to go in and say, as an example, we can change the fill holes, so maximum of holes of 4. And can you zoom into a couple of those areas and let's filter for that? So let's do a filter for bad faces and the model from an interactive standpoint. And you can go in close and see exactly where the imprecisions are on your screen. And then if you also notice, there's some free edges there with some open faces, Marco, in yellow. Yep, right on the bottom. So it says in our scripting language that we created is that when we see something like this and they're all connected free edges, you actually have the ability to go in and clean that. Excuse me. So go ahead and run this heal model on here. And when you run it, you can see it went down to 16 imprecisions. And so we're going to take the second action that we took and stitch the model. So it went through now and there's 4 or 3 bad edges. Now, why do those bad edges still exist? You think to yourself it would be fixed, but the word tolerance is a big thing in the industry. And so you have to make sure that your tolerances are set in your system. But now you have 100% clean face and clean model. I'm going to take this exact model now, show all, say, okay, if we write this out, we're thinking to ourselves, there's no errors. But what happens when I take this exact model, Marco, and translate it? And I'm going to translate it to CATIA. So we go to our translation and we're going to translate this to CATIA. And we're going to leave the configurations just the way it is. And because CoreTechnologie has the ability to open up any CAD file without a CAD license, so we're not having to go out and access the APIs, we're able to gather more information. More importantly, from a writing standpoint, we also have the ability to write out both CATIA and AX without accessing the APIs. And this is a lot of reasons why we're selected in the industry, because we're not dependent on those APIs when you're implementing into PLM systems or trying to implement automated process. So go ahead and do a conversion on this. And we're not going to save the file, but what I want you to notice is now that's interesting. So what it's telling us is that there's still 6 imprecisions or 6 bad faces. So although we clean the model in CT's file, if we convert this to CATIA, we're going to end up with some bad faces. So go ahead and heal it, and let's just see what happens with these imprecisions. So the kernel CATIA would still consider this not a solid model. And once you stitch this, you'll still end up with 1 bad face. It's over, if you notice, that 0.01 tolerance that we're using. So what that means is we can either leave this or we can clean it manually. So why don't you just clean this one manually and just heal it? So we'll choose the 2 faces and we'll go ahead and heal the model. And so we chose the original face and then we chose to stitch, the second one, and now it's a clean model. Let's do the exact same thing, but now let's write it out to NX. So for those that are in the CAE department, they know that either a Parasolid or an NX file is going to have additional free edges. So now, from there, we find out what? That there's still going to be some imprecision, so it will not be a solid model. And to read this into the CAD file, or even a computer-aided engineering software or manufacturing, you would know where those imprecisions are very quickly. So in this case, he was able to clean it very quickly. So that's great, David. Now we got a solid model. But let's ask ourselves, if we get the same model, and now I'm submitting this model to an OEM, whether it's in the aerospace industry or the automotive industry, and they tell us that when we submit a model, we have to do what is called a product data quality check on the model. And I'm going to use Nissan as an example because they were one of the very first components over 20 years ago where they created what would be called a product data quality based on their 16 different categories and checks. And so what they did is they said, okay, I want to do a check on the model based on, in this case, we're using a VDA check, but I want you to know, Marco's pointing out that you have the Sussex and you have the, I don't know how to pronounce that word, but it's I always just spell it out, ODETTE. So those are the quality standards in the industry. But we're going to use either the VDA or the advanced check. Maybe we use the advanced check in this case, because it's already determined based on our experience in the industry what's checked. So if we look, can you go back to that for a minute? I'm sorry, Marco. I apologize. I wanted to explain, so in any product data quality standards, you are going to check for curves, surfaces. If you click on the surfaces, there might be tiny elements, in this case, self-intersecting loops are selected, or curvature radius is selected. Go to faces. So you got tiny elements and overlapping elements up to 0.02 millimeters. And then topology. There you got G on the topology free edges and GO continuity, not G2 continuity. So let's just do a check and see what happens here, Marco. And what is the results of those checks? So it looks like we just have a couple of bad faces here, and let's just see what happens. Oh, it looks like we have some twisted surfaces. Why don't we try to find those twisted surfaces very quickly? We're going to view those alone and zoom in on a couple of those. And let's try to understand the control points of the NURB surfaces on this. So we're going to display your, oh yeah, this makes sense. So where does this become a problem? It becomes a problem possibly in manufacturing. And for sure, there's a problem in the computer-aided engineering. So if I try to put a mesh on this, it's going to put the mesh or the NURB surfaces on the control points. And this could cause a problem with the solution. So unique to CoreTechnologie is the fact not only can we determine your product data quality standards, but we can heal based on the advanced quality checks that you've identified. So let's go to our heal function on this, and let's, instead of looking for a basic heal, we're going to use the advanced check that we just checked against. any of the model. That's interesting. It didn't do that one. Can you rerun that again?
It went down to only one, so it's here all of them, but still missing one. Usually
Okay,
that gets here when you do the stitching at the end.
okay, go ahead. Okay, can you find that same area for a minute? There you go. And then zoom in on that. Now let's take a look at the control points now. I want to determine what face, if you can see the, so now you have new control points.
Much better.
So this is much better. So I kind of mentioned Nissan earlier, right? So let's go back to our checking of the exact same model, only this time, I'm going to go to your advanced check. Yeah, advanced check. And I want to specify specific checks in this model instead, because I know that they have certain requirements. So go ahead and we'll create a new profile. And in this case, we're going to call this custom. Okay, that's fine, a custom advanced. So now we're customizing this based on our standards or a standard from a specific customer. And in this case, I'm really interested in tiny relevant segments of the curves because those are weird. And then G1 and G2 continuity of the curves, but I also want the G1, G2 continuity of the surface. Oh, that was great. Marco, can you also kind of show? So in each instant of our product data quality check so that you understand what you're looking at, it kind of shows you, in this case, the curve that's created and where or what is defined in a picture, the tiny relative segments. So let's look at the surfaces for a minute and let's see if there's G1, G2 continuity. And I also would like tiny elements, right? So now you can see where the curves in the G1, G2 continuity. I will tell you that I once had a customer that was using this, so to some extent they were actually asking us to add the G3 continuity, but I really think that if that's very rare in the industry. So you can change your millimeters if you want, or your degrees if you notice. So if you want it different, you can. We're not going to change it. We're just going to keep it the same. And then let's look at the faces. Here that's checked in the advance. Yep, this is fine. And then the topology. Great. So let's go ahead and do a check on this. And now there's no error. So what we were able to do so far is we were able to go ahead and heal this model to a solid model as a CT file, if you will, or a neutral file format. That CT file, keep in mind, is a duplication of step. But what we also were able to do is go in and define specific parts of the part or the assembly. We can do it in a full assembly too. And then have those healed based on advanced quality checks as well. And then also create a specific profile to the model itself. So that's great. So that's related to the core competency of data translations and the challenges in the industry and how quick our technology does it. I'm going to ask you to open up the advanced window for a minute. Can you do that, Marco, on your side?
Here?
Yeah, the advanced, the shell window. I'm sorry.
Oh, check window.
And can you reopen up this model in a new window, please? So how does the shell window open? So go ahead and copy and paste everything except for the last two items. All the way up, all the way up, and copy. Yep.
Up to there.
Yep,
right?
copy. And now go back to your new model.
And paste it.
Yeah, but this is this your new model?
Yes, this is the new one.
Yep, and just paste it and hit enter. And now what it will do, if you notice, everything that Marco did earlier in the presentation can be batched out. And now you're not having to repeat it. So when we talk about the engineering chore, this is creating your own scripts. And it's redoing everything that they just did in less than a minute. I think I have a second. So kind of keep in mind when you show the Enterprise Data Manager, that's how we take the scripts. So let's move on to another area of my presentation. I want to show, so we kind of covered also converting to CATIA V5, V6, and Creo. We also covered, I should let you know that you can also write this out to a JT file. You can also write this out to a 3D PDF, which I'll show in the next area. Can you show something with PMI now? So I'm going to talk a little bit about the next checks that have happened in the industry. So when CoreTechnologie said they wanted to get into the validation properties and they wanted to create product data quality as well as long-term data retention, rather than us doing it on our own, we decided to join a consortium for LOTAR and PDIS. And what our idea was is why recreate the rule when the industry is creating the standards in the industry. So one of the thoughts in our very first project that we did with NIST, which was a great project, we actually developed a part or created it. I actually have it sitting on my desk. And from that part, we actually ran it through the whole entire product data design process. So from design to computer-aided engineering to computer-aided manufacturing using a Step 242 format. And if those that don't know who it is, what Step 242 is, it was the consortium LOTAR that developed the Step 242 Edition 1 and Edition 2 for the product data quality standards for the aerospace industry was the focus, but we're finding that a lot of companies are starting to use this file format. So this is one of the NIST files, and what we wanted to kind of teach you in this area. So as you can see the part, can you click on one of those PMI? Kind of show people. So when you click on this PMI here, you notice that it references a specific area in the geometry. So what does that mean? So there's the word semantic representation and non-semantic representation. In this case, CoreTechnologie reads the semantic representation of the file. And so it will actually point or reference to that geometry. So this removes the 2D associativity. So when you talk about, well, we're starting using 2D drawings, if you have a visualization tool, which CoreTechnologie offers as well, currently we're showing you this in our product 3D Evolution, but you can open up this 2D drawing, 3D drawing with the PMI data or the GD&D data attached to it. And Marco, you want to touch on your PMI check here, and I'll pass that portion over to you.
Yes, so within our battery of testing, we have a specific check for PMI. You can actually customize it. So if you go into edit profile, you can see that for the standard checks are turned off for this one. We are not using any VDA or JT or feature, but if you go into the validation part and you select the proper category, you see that all of these are selected. With a certain threshold, for PMI, when you don't say semantic PMI, it means that it's just a standard or tessellated PMI. which is just text made out of curves. So they do this because some of these formats out there do not fully support all of the entities defined as PMI. So in order to make that compatible, you convert that text to lines and points instead of being semantic PMI. So that allows you to send PMI to a lower system that doesn't really support it. But we have checks for that. So when we have PMI that is non-semantic, you can still compare and check that PMI and make sure that the curve length made up of all of those curves still is the same as it was before. The centroid for it, the areas, all the tessellated areas, the number of views included into your visualization is the same, and more of them. And as for actual semantic PMI, of course, you check the contents that it matches exactly, letter for letter, word for word, what was there before. The number of nodes, because well, if you're going semantic, that means that you are converting from a semantic entity into a semantic entity. And sometimes as I said before, your target system may not support that specific entity. So in that case, that node might be lost. And that's why you check the number of PMI, because you want to make sure that they match what you are supposed to have. And it also separates the number of PMI per type. There are many different types. Then the location, of course, the geometric tolerance block, the datum feature, the area where it's at, and so on. So in here I have enabled all of this. So I'm going to go ahead and do a check. So it shows that I have 0 errors based on those categories. If I want to see the report, I just bring it up and I can still check again what was I checking for. So all of these categories within standard PMI, all of these within semantic PMI, and within those categories, none of these turn out to be a problem. So we have the same number of views that we should have, the same number of annotations. And let's look at the save views. So we have our standard views from top to left, and then we have one MVD view. So the MVD views are the views of the combo view modes of that you might know in Creo. Those are uh, preset views with a certain zoom level and orientation, showing the nodes that should be visible at that specific orientation. So if I rotate this around, you can see that some of these nodes are in the wrong orientation. So that's why we have these views. So when you select one of those views, it will automatically default to an angle that you can read all of them, like I just did now in our custom views box. You can see that all of the text is visible, and it's made that way, and that's why this view was created. So that's something else that you also check for.
Yeah, so one of the things that our customers have asked for is, now that I've interrogated it, when you do have something wrong with it, let's see what this looks like in a PDF. Because they don't have 3D evolution. They don't have anything. So if I were to write this out to generate a report to PDF, it would automatically create a report. Can you click on that report? Yep. And then open up that PDF file. It should, I think it
Yeah, I need to enable the JavaScript.
Oh yeah, this
Hold
is
on.
a different machine than you.
Yeah.
Sorry.
Just as a time check, we have about 10 minutes till the end of this topic in specific. So to our attendees, if you have a question or if you have something you'd like to see again, please do use either the Q&A function, chat function, or raise your hand, and we will take your question that way and hopefully display the solution.
You can just cancel that and close it, and it will show it in the background maybe.
Okay.
Yeah, that's Adobe doing its thing. But the idea is that you'd be able to open it up in a PDF, and it would give you, there you go.
There we go.
And so not only is it giving you the 3D model for someone to check on, if there was an error and you wanted to create notes or annotations, you would be able to do that as well. And then you can specifically look at the captures or the body or the parts of the assembly You also have on the left-hand side where it says geometric, there's your isolated views in there, but you could change, in this case, it was GVP check on the geometric, you can change that as well. And then one of the questions it looks like that's being asked here is, can you customize the template for the PDF? And the answer is yes. We currently work with our development team to take your specific template and be able to build the template for you. But if you haven't used 3D PDF, it's pretty user-friendly. I always see something new with it. So if you're doing a technical package and you want to also write this out to a JT file and you want to embed this PDF file in a JT file or embed the step 242 file in, you can. So I have about 4 minutes. I'm going to show you our GVP check using a little bit more defined checks that are based on the consortium standards. So, thank you, Marco.
So you can run GVP check at the part or the assembly level.
Mm-hmm.
So here we have examples of both. So GVP check stands for geometric validation properties. So this is just a set of metadata that gets attached to the model when you translate it to step. So let's say that you got this part and has a specific mass properties like area, volume, surface area, and mass. So when you are translating this to a step and you are following the GVP standard, it would calculate those properties at that moment just before writing the file. It will stamp those into the file as static metadata, and then it will save the file. So the GVP and the loader standard means that you can validate this file against itself. So you don't need the original one in order to make sure that this is a good derivation of the source file. Actually, all that you need to validate this file is already included in it in the form of these properties that were stamped into the file at creation time. So what you do is that you load up the new file. So let me get this one in place. So the properties that represent the correct values are the metadata that was stamped in here. So now when you do a check, it's going to calculate those properties again in real time based on what you actually have on the screen, and then compare those properties against what we know should be the correct values, which are the values that were stamped during creation time. So basically like a cargo manifest, you are comparing what you're supposed to have against what you have, and then you open up the report, you see that, okay, this is the original area that we are supposed to have. And this is what we actually have. And this is the deviation, which is almost nothing. Then the center of the part, just to know if the part shifted around during conversion, well, it's pretty much spot on. It's less than 1/10,000 of a millimeter. And then the volume as well is pretty much spot on as well. So we can do this because during creation time, these properties were saved to the model. And these are static. Nobody can come in and change them. So whenever you come and modify this or validate this, you know that you'll be within the tolerance or within the spec. So this is what GVP does for you.
Yeah, and I think what's interesting here is, Airbus was the very first company in the world to put this process in place all the way downstream, from CAD to computer-aided engineering to computer-aided manufacturing. In some cases, they wrote out the file to CoreTechnologie, and in some cases, they wrote out the step 242 file from CATIA. So we ran all of this in a batch process for them to determine that process for them. And since then, because we're at the consortium and all the engineering guys hang out together, Lockheed Martin uses this as a reference account of ours. We have a couple of newcomers coming along, but Honeywell also implemented this as a GVP check and the step 242. So although you're not hearing about step 242 today, it's my belief that in the next probably 6 to 18 months, this will be a de facto standard, because we're already releasing and hopefully being certified for edition 3 by the end of this year. And if you want more information on this process that's used, or you want to learn about the consortium, please don't hesitate to contact CoreTechnologie. And at this time, I have run out of time. But Michael, I know I'm out of time. Can you just take this file and save it with decimation, or show them the results of it? So one of the things that happens in the industry is sometimes you're just visualizing a file, and we use market-ready geometry, MGR decimation. We use this file to reduce the file size, because some of these files get really large. And he's just going to take this file size and just hit file and save, but he's going to decimate it. And when I talk about configuration of decimation, he's going to change the minimum sag to 2 on this and convert it. And then save the file.
So it's actually already pre-saved, and I calculated number of different values for that pre-sag. So just so you see how the geometry has been simplified, but it really looks exactly like it was before. There has been no real degradation in quality, other than the file has been decimated. So when you look at the size using 2 millimeter sag, you can compare that it went from 90 to 19 megabytes.
That's almost 18% reduction without even doing anything except for file save.